Okay, let's do a little more practice with I and J. So this next one wants me to give A. A goes over 1I, and then it goes up 1J. So A would be the vector 1I, 1J. Let's look at B. B goes back 3 up 2, so that'd be negative 3I, 2J. V goes over 1, down 1. And W goes back 1, down 2. Okay, the next problem says find all the vectors in 2 dimension having a magnitude of 17. This stands for magnitude. Sometimes we'll use 1 bar to represent magnitude of a vector. Sometimes the book uses 2. It just kind of depends on who's writing the question. But keep in mind that means magnitude. I'll remind you of that. And the J component is 8. So I'm going to draw this vector. I'm going to draw it at the origin because it doesn't matter where we place it. And I'm going to draw it 2 different ways. I can draw it like this, which is the hypotenuse is 17 because that's the magnitude. The Y component is 8 because we go up 8J. And then I could draw it like this as well because that also has the same Y value of 8 and the same magnitude of 7. If you do the Pythagorean theorem here, you get 15. So this would be negative 15. So when it asks for the 2 vectors, what it's asking for is the vector over 15 up 8 and back 15 up 8 is your 2 vectors. And my guess is you can enter them in either way. You could enter this one in as 15I plus 8J, and you could enter this one in as negative 15I plus 8J if you wanted to as well, I'm guessing, but separated by a comma. The next problem is problem 12. It says, what is the terminal point of this vector based at the point 5, 4? So I'm going to graph this real quick. So we start at the point 5, 4, which is right here. And then what this says is we're going to go over 5 up 2. So we're going to go over 1, 2, 3, 4, 5, and we're going to go up 1, 2. So we translate by that amount, basically. And the terminal point is the point at the end of that arrow that we're looking for. So we would add this, and we go, this would be 10, 6 if we add them together. And let's use regular parentheses here because they asked for a point. So be careful about that. Next question is a really easy one. We want to add the x's and add the y's together when you add vectors. So this is going to be the vector 8, 3. And don't forget to use the vector pointy brackets on your keyboard above the comma and the period. Next one's similar but a little bit more difficult. When you add these together with fractions, we got to add 5 over 2 plus 1. So I'll make this 2 over 2. Get a common denominator, so that'd be 7 halves. Now I'll add the y's together, so we need negative 7 thirds plus 10 thirds. That gives me positive 3 thirds, which is just 1. So this would be 7 halves comma 1 for me, using the pointy brackets. All right, and the last question says determine whether these vectors a, b, and pq are equivalent. Vector a, b, I'm going to find it in vector order pair notation. I'm going to do head minus tail rule, so I'll do negative 3 minus 4, it gives me negative 7. And then I'll do 8 minus 4, and that gives me 4. I'm sorry, negative 3 minus 2 is the y coordinate, which is negative 5. And the x coordinate is 8 minus 4, which is 4. Completely messed that up. So you do head minus tail, so I'm going to do y minus y, negative 3 minus 2 gives you negative 5, and x minus x, 8 minus 4 gives you 4. So it's the vector 4, negative 5. Let's do the same thing with PQ. So this is AB. PQ, we're going to do the same thing. We do negative 4 minus 1, which is negative 5 for the y coordinate, and 4 minus 0, which is 4 for the x coordinate. So both of these vectors go from over 4 down 5. So they both go over 4 down 5. So if you were to graph A and B, you'd see to get from A to B, you'd have to go over 4 down 5. If you graph P and Q, you'd see that to get from P to Q, you'd have to go over 4 down 5. So they are equivalent.